Okay, you also have to learn about the types of operating system. You need to understand different types of operating system and analyze an application. By this I mean a situation, and decide on the type of operating system it requires. To do this, you've got to describe the characteristics of different operating systems and describe a range of situations, applications that require a certain type of operating system. Let's first identify the different types of operating system. There are 6 that you need to know about: batch processing, real-time, single-user, multi-user, multitasking, and distributed systems. Start off with batch processing. When computing was a new discipline, there was not enough machines to satisfy demand for process time for students who wanted lots of calculations, or firms who wanted their payroll worked out, or many other situations. There are 2 solutions: buy more machines, or remove the slowest part of the system, i.e. the human being. To buy more machines obviously would be a very expensive situation. So what we need to do is remove the slowest part of the system, which is the human being, so that the machine was doing it in an automated manner as much as possible. So what do we mean by that? Think about it. The computer is much quicker than you. If you take 30 minutes to type in data, the computer will probably process it in a fraction of that time. It was decided that it would be more cost effective to remove the human from the system than purchase what used to be very expensive machines. All the data will be collected and is run in a batch in one go over a suitable time period. So, when we would use this? When we've got, this is an example of an answer that you would have for batch processing, so this is very important. I'd suggest you make notes on this. A large amount of identically formatted data is collected over a period of time. Output does not have to be done immediately. Human intervention is not necessary when you're processing. The data requires similar processing. It is then processed at a suitable time, often late night or on a weekend when user involvement is not required. Examples might be payroll for employees in a business, or bills from customer records, e.g. your water, electricity or telephone bill. Note, do not put in the answer that it is processed at the same time. So here where we've got at a suitable time, it's not the same time. That's because the data isn't all processed at exactly the same time. Alright? Data will be processed one piece after another, so therefore not at exactly the same time. Right, the next one we need to look at are real-time systems. A real-time system is one where the processing is done quickly enough to affect the next input or process to be carried out. Learn this as a definition. It's a good answer for an exam question that will get you 2 marks usually. So what does this mean? Most real-time systems are based on the control of some process in the real world or on information handling. Essentially it means that all the processing is done almost instantly. Think about if you were playing a computer game. If you shot someone in COD and the processing wasn't real time, then they wouldn't die. They might be able to get off a shot afterwards and you may find that you both died. However, if it was real time, then this shouldn't happen. If real time wasn't used, then there would be a lag. Just note that you do sometimes see a lag in something like COD, but it's usually down to the internet connection. And it's not down to the processing. So let's have a look at this. The robot trolley example. A robot trolley is controlled by a processor which takes input from a sensor following a black line on the floor. It makes decisions concerning steering to keep the trolley on the black line. If the processor was not controlled by a real-time operating system, the trolley would very soon leave the black line because it would not be steering quickly enough. This is an exam question that comes up. In a robot trolley, what type of system would you use and why? Well, we'd use a real-time system because we have to have the robot make a decision quickly as to whether it is going off track, off the line. If this was the robot, it would then need to readjust itself every time it left the line. If we go back to the definition, the processing is done quickly enough to affect the next input or process to be carried out. So we're following the line. The process is done quickly enough so it affects the next input, so we keep following the line, as opposed to potentially if we were using a batch process and we were going to process it at night time, the robot goes off the line and keeps going until it gets time to process it again. So this is why we use a real-time system. Right, the next example, ordering systems. You should all seen. Catalog shop processes orders according to the code for a product, which is input, and the system then compares the code with information in its files. When it finds the correct code, it can report to the user the number of that item that there are in the store. If there was only one left of a certain item, it would be necessary to record the fact that a shopper had bought it before the next shopper has their request dealt with. Otherwise, the second person might be sold the same item. So, I buy an item, it will take off the fact that I've bought that item. If you go to buy that item, then you can't buy the same one if there are none left in stock. Should be quite obvious. Similar sort of principle, the booking system. Airline, concert or theatre booking systems are real-time systems. If a customer inquires about whether there is a seat available for an event and is told there is, they go ahead and book the seat. The number of tickets must be updated, otherwise a second person may be sold the same seat. This system helps to ensure the seats aren't double booked. So same principles as the ordering system. Right, in a real-time system you have a high redundancy rate. This is because the information on the system must be processed immediately. The operating system needs to be ready to handle input as soon as it comes in. This means that it cannot be using up some of its slack time doing other tasks while it is waiting to be asked to do something. This implies that the computer will be not using its full potential as far as processing is concerned. So there is a lot of wasted processor time. It is as if the process time is being wasted, but if it was being used for something, then it would need, when it was needed for the real-time process, this could cause issues for such a system. In other words, if the processor was being used for something else, and then suddenly the robot left the line, and it took a delay, the robot would go further away from the line before the processor took control again of that process. So we need a real-time system in that situation. And we cannot use the processor for anything else. Right, a single user. This one is one that you should know from home. Only allow one person to use the computer at any one time. Don't confuse this with the machine only having one user. You could have several people using your computer at home, but not at the same time. While you search the web, can your friend be playing a game? While you type up an essay, could your little brother be searching the web? Alright? No, they can't do the same thing at the same time. Here's an exam answer. Allows one user at a time to use the system, allocates each user with rights, keeps the user files separate. To remember this, just remember what your operating system does. You have a login for you and your family. You cannot see their files and they cannot see yours. You have a login with username and password. So all your files are separated. Multi-user system. Multi-user system allows more than one user to use its services simultaneously. Here is a description of a multi-user system for an exam. This has a single computer which is connected up to a number of terminals. These terminals are not computers as you know them on a network, but are limited machines with minimal processing power. Each terminal is given a time slice. Each time slice is very small, 1/100th of a second. Uses flags to identify something needs processing. Terminals are given priorities or privileges. The data is separated. Security is essential as all data is on the same machine, therefore user rights are set up. So the main machine will have all the data. An example of this would be a supermarket checkout system where you have lots of mini terminals, but then you'd have one main computer that serves all those terminals. And online gaming is another example of time sharing. And mainframe serving many terminals again. So let's have a look at the gaming one. Think about when you play a game online, there is a host computer. That host computer controls all the other computers and runs the game. As an aside, if the host computer is not powerful, it can cause issues within the game. So the server of this type of system needs to be powerful to secure more than one user at a time sufficiently. Every time something happens that requires processing, the client machine will set up a flag and the host will then process the data when it passes next. The clients get a small timescale before the host passes on, processing to the next machine. Imagine if the security wasn't set up sufficiently though. Every time you're playing your game, there could be potential for someone else to get into your data on the host. They could alter your kills or control your character even. The mainframe example. Think of the same setup, but within a mainframe computer. There is a host computer. That host controls all the other terminals. If the host computer is not powerful, it can cause issues with the client. So the mainframe computer for this type of system needs to be powerful to serve more than one user at a time sufficiently. Every time something happens that requires processing, the client terminal will set up a flag, a keyword that we see again and again, and the host will then process the data when it passes it next. The clients get a small time scale before the host passes on processing to the next machine. Certain processes may get priorities within the system. Imagine if the security wasn't set up sufficiently in this case. Someone could get into your files and possibly copy or even delete your files. Multitasking allows more than one application to be available simultaneously. When you use your computer at home, you might have more than one thing open at the same time. E.g., you could have a spreadsheet open, a Word document that you're copying data from the spreadsheet into, and music playing, and the internet open, all at the same time. Let's have a look at multitasking. This is an example of an exam answer. More than one task program can be open at the same time, and each apparently runs at the same time. User can switch between programs. They only appear to be running at the same time. The operating system switches back from one task to another very quickly because the processor is so fast you don't notice the difference. A round-robin system with each task allowed a small amount of process time before the processor moves on to the next is used. Different programs are available in different windows. Single user system will use multitasking usually. And a student listening to music while working on a spreadsheet is a good example. And you generally ask for an example in this sort of system. This usually comes up in the exam, so I suggest you learn all these points. Last one, a distributed system. This is where software and data files are distributed around a system. So an ordinary network will have a server controlling the network and access the hard drive. However, a distributed system might store the word processing software on one computer's hard drive while the files are stored somewhere else on another computer. The spreadsheet software could be installed on a different computer, so that all the resources are distributed across, the software is distributed across the different computers within the network. This can speed access to files because there's no single bottleneck which all the information must pass through. So they are all our different types of user interface that you need to know. And let's go back further to the title screen so we can see what we've just gone through. Sorry. Yeah. So we've looked at batch processing, real time, single user, multi-user, multitasking, and distributed. I would suggest you make some notes on these, get some pictures that might help you remember certain aspects of them. So what we've covered are the different characteristics of different operating systems, and we've also looked at a range of situations that might require a certain type of OS. They're the things you need to know for the exam. Make notes on this topic. It's not too difficult one. Most of these you will have experience of before. As we said, real-time, single user, and multitasking you've got experience of, so it's a case of applying that experience to remember it in the exam. Batch processing you might have some experience of. Multi-user and distributed you will probably need to learn. Okay, good luck with that, and we will see you again soon.